What's up, geometry students? We are going to talk about our friend Mr. Pythagoras, who discovered that if you want to find these diagonal lengths, you know horizontal lengths and vertical lengths. And we are understand that these lengths show up very naturally when you're using a coordinate grid. Points are like horizontal distances and vertical distances from the origin. He discovered, and we showed in the proof, that if you sum the squares of the lengths of the legs, you get the square of the hypotenuse. This is very important. Very important. This C is always the hypotenuse. The hypotenuse is what we call the largest length. It's opposite the largest angle. So it's got to be by itself. And then the legs are A and B. These are the shorter lengths. Okay. Um, we are going to be finding lengths of right triangles using the Pythagorean theorem. It's pretty simple. Let's say this is 4, and this is that doesn't work out. 2, cool. We'd say, okay, what is C? I would get 4 squared plus 2 squared equals C squared. 16 plus 4 equals C squared. 20 equals C squared. And it's like, cool. C times itself needs to equal 20. What is C? Well, we then introduce the idea of a square root. A square root is like the backwards of squaring. So we know that like 3 squared equals 9, right? Well, we would say the square root of 9 is 3. It's like the backwards squaring. 4 squared is 16. We would say that the square root of 16 is 4. Cool? Now, here's a problem. What number times itself is 20? Well, we don't know. So sometimes we'll have to just write our answers as the square root of 20 and not be able to simplify this to be a whole number. I could even break out my calculator and show you that the square root of 20 has got to be a number between 4 and 5. I know that the square root of 16 is 4. I know the square root of 25 is 5. So the square root of 20 is somewhere between. Now, it'd be nice if we could say we're done. This is the answer. However, we as mathematicians like to be able to work with numbers as much as possible. This is not a number that's easy to work with. And if we were trying to work this number with, say, other numbers that we would want to, like root 45, like let's say we wanted to add root 45 and root 20, we would not be able to do that. We would think that it's root 65, but it's not. So this is when we simplify our square roots. Now, simplifying square roots, simplifying radical expressions, there are many, many different ways to do it. You might have been taught a different way to do it in the past. I try to keep it simple. I try to say, square roots of a lot of numbers. You know the 8 squared is 64, square root of 64 is 8. You know that square root of 49 is 7 because 7 squared is 49. You know 36, 25, 16, so on and so forth. Well, our goal is to figure out which of these biggest square roots can be kind of extracted from the square root of 20. And we use a very, very important property, which is like if you can write 20 as 4 times 5, you can write root 20 as root 4 times root 5. Root 20 is root 4 times root 5. Now, why didn't I use root 10 times root 2? Because I don't know what root 10 is. It's not one of these perfect numbers. I don't know what root 2 is. It's not one of these perfect square roots. So, why did I choose 4 and 5? Because I do know root 4. Root 4 is 2. So since root 4 is 2, I say my answer for C in simplified form is 2 root 5. Now it's very important to realize root 20 is the answer. Like 4.4721 squared is 20, which is a squared plus b squared. However, the simplified radical form is 2 root 5. It's the same number, okay? So, step 1, Pythagorean theorem. Step 2, simplify our radicals. All right, this is like how I introduced the concept in class. It's like I drew a line. Turns out there were like points behind it. Shows us vertical distances and horizontal distance. What did we do last class? We found the slope, right? A rise over a run. Well, guess what? The rise gives you a vertical distance. The run gives you a horizontal distance. It gives you a right triangle. So like coordinate systems love right triangles. Oh, from 9 to 6, what'd you do? You went down 3. Now, you could say it's -3, or you could say that length is 3. Oh, from -1 to 8, what'd you do? I went over 9. You could count over, and you're like, oh, the slope is 3/9. That's not the question anymore. Those numbers are important, but we're not going to use it for a slope. Rather, we're going to use it to find this length. Okay. A squared plus B squared equals C squared. 3 times 3 is 9. 9 times 9 is 81. 9 plus 81 is 90. Okay. That means C is the square root of 90. Great. Leg 1 was 3. Leg 2 is 9. C is the square root of 90. Now here's our goal. Let's try to extract the largest perfect square from that. Start with large perfect squares. See which one is going to divide out of 90. We want to try to find the biggest one. If we don't find the biggest one, we might have to do a little bit more work while we're doing things. But I can see that this list is going to help me. And I'm thinking to myself, okay, does 25 go into 90? I don't know. You could check if you have a calculator, like 90 divided by 25, and you're like, no. Oops. I thought that was divided. 90 divided by 25, you say no. Can I take 90 and divide it by 36? No. Can you take 90 and divide it by 9? Oh, yeah, I can. 9 times 10 is 90. So I can write root 90 is root 9 times root 10. Now, why do I put root 9 first? Because root 9 is a value that I know. Root 9 is just 3. So C is 3 root 10. This is what's called simplest radical form. 2. Yeah, like I wish we had like more easy ones, but like this is a good one to do just to challenge you. This entire length is 19. This length is 9. Try to subtract 9 from 19. This must be 9 over here. So what is this? This must be 10. 9 plus 10. This must be 8. Here's our right triangle. We have an 8. We have a 10. What is x? X is the hypotenuse. So I'm going to set up that 8 squared plus 10 squared equals my c squared, which is x squared. I got 64. I got 100. I got 164. Now, it could be that if you have a calculator, you just start like dividing 164 divided by, I don't know, maybe like 49. So no, 164 divided by, I want to try something large, like 16. And no, so I end up doing 4, but I feel like maybe 9 works. But let's say I just like give up and I just do 4. Actually, that does work. 4 ends up being the largest one. So we just saw that 4 times 41 is 164. That means root 4 times root 41 is root 164. root 4 is 2. 2 root 41 wins. Yeah, that's fine. Was the length of the dotted line. Cool, we know this is 7. And we can see this other right triangle that is a 9 and a 9. So I'm going to actually have to find this x first, and then I'll find x to find y. This is a good question. We're going advanced into the Pythagorean theorem pretty quickly here. So if you are struggling, I would advise you draw just a couple right triangles and come in, and I will help you with easy right triangles first before we go into these more advanced problems. All right, so I start with 9 squared plus 9 squared equals x squared. X is opposite the hypotenuse, so I get 81 plus 81 is x squared. 81 plus 81 is 162. You could also say it's like 2 root 81s, but like 2 81s. But let's just start with that. Okay, so x is the square root of 162. Now I could actually simplify that, but I actually don't want to, because watch what happens. Now I get this squared plus this squared equals this squared. So the second triangle is root 162 squared plus 7 squared equals y squared. Now, watch this, guys. If square rooting is like the opposite of squaring, what happens when you square a square root? Yeah, you'd be correct in saying they would go away. There are some situations where actually doing the simplification was not going to help us. This is easier. Now I get 162 plus 49, which is a big number, which I don't like. And I get 211 equals y squared. Now I'm trying to figure out, can I divide like 9 into that? I know I can't divide 4 into it because it's not a perfect, it's not even. I don't know if I can divide anything into it. So I actually think, and like this is freaky for a lot of us, because like, when do I know when I can do it, when I can't? Just try, try, but square root of 211 is the answer. Okay, I like this one. 4. We like went from like, okay, this is fine, to okay, that's hard, to like, oh, that's really hard, to like back to being like nice and easy. So like, make sure we can do this. Okay, well, hey, this is a leg. This is a leg. This is the hypotenuse. Okay. Now it doesn't matter if you have this as A and this as B, or this as A and this as B. It doesn't matter, because when you're adding things, order doesn't matter. But A squared plus B squared equals C squared. 16. There are middle school football coaches yelling at middle schoolers. It's kind of funny. And I get B squared equals 33. Great. Let's try to simplify this. Well, like you could write 33 as 11 times 3, right? That doesn't help us. Like, here's where a lot of students go. They're like, okay, B's got to be the square root of 33. But then they're like, oh, 3 times 11. But here's the problem. I don't know what the square root of 3 is. I don't know what the square root of 11 is. They don't simplify. We need to be using numbers that do simplify. So this is a situation where the square root of 33 is just the square root of 33. 9 doesn't go into it. 16 doesn't go into it. And then obviously 36 doesn't go into it. So we just stop. All right, another easy one. Great. Okay, notice that This is our C. This is opposite the 90-degree angles. Here's our A. Here's our B. We're trying to find the B. A squared plus B squared, or let's flip it up. Let's call this our A. This is our B. This is our C. Doesn't matter which order we do. Okay, you could either do A squared plus B squared equals C squared, or you could do A squared plus B squared equals C squared. You know, like doesn't matter. A squared plus 9 equals 36. 9 plus B squared equal 36. So choose your own adventure. It's 27. 27 plus 9 is 36. Now we can simplify the square root of 27 because I know one of my perfect squares, the square root of 9, is 3. 9 goes into 27. I will write 27 as 9 times 3. That means root 27 is root 9 times root 3. I do this because the square root of 9 is 3. I get 3 root 3. This is what I'm looking for. That's simplest radical form. It's the same as our answer here. 9 plus 27 equals 36. All right, this is one of those hard ones. Kind of scattered in hard ones and easy ones. All right, this is 2, this is 3. What is this? This is this, that's that, that's that. We got an A squared, a B squared. We're trying to find this Y. We'll then use the hypotenuse 6 and this leg to find this leg. So we start with 2 squared plus 3 squared equals Y squared. I'm just going to leave it as this. Just going to leave it for that because watch. X squared plus Y squared equals 6 squared. This triangle has got that 6. Well, I know Y squared is 13. It's just like if I said Y was root 13, I'm going to have to square it. And root 13 squared is 13. I hope this makes sense to you. Why I can just say this is 13. X squared is 23. X is the root of 23. Now, does 4 go into that? No. Does 9 go into that? No. Does 16 go into that? No. That's simplest radical form. Okay. I'm going to find this C. I don't want to call it C, so I'll call it like this Y. Once I find this Y, I'll be able to find this X. This X is the same as that X. Okay. So first triangle, A squared plus B squared equals the C squared. Make sure you notice that's the hypotenuse opposite the 90-degree angle. 25 plus 64 equals Y squared. 89 equals Y squared. Now let's figure out, is there a nice perfect square that goes into 89? I actually don't think there is. So let's divide it by 9. No, it doesn't work. Let's divide it by 4. It doesn't work. Let's divide it by 16. It's not going to work. Let's divide it by 25. No. By 36. No. By 49. No. So like we're good. And honestly, we should be leaving this whenever you're using like two triangles on the Pythagorean theorem. Watch how you'd say like x squared plus y squared equals 10 squared. Oh, well, I know what y squared equals. Y squared equals 89. Should have done this earlier. So x squared plus 89 equals 100. X squared equals 11. X has to equal the square root of 11. Can I simplify this? Well, does 4 go into it? No. Does 9 go into it? No. All right, this is the same deal. Now this is X. This is 2. This will be Y. Okay, so we have leg, leg, hypotenuse, which turns into a leg, leg, hypotenuse. So I got 4 squared plus 10 squared equals X squared. 16 plus 100 equals X squared. X squared equals 116. Then the second triangle, so this is number 1 here. This is number 2 here. Number 2, I have X squared plus 2 squared equals Y squared. Well, X squared is 116. 2 squared is 4. Y squared, we have 120 equals Y squared. They ask you to round to the nearest tenth, but we want simplest radical form in this class. So we will take the square root of 120. What's a big perfect square? I know 4 works, but sometimes you got to be careful because if we choose 4, can we get another perfect square out of 30? 4 doesn't go into 30. 9 doesn't go into 30. 16 doesn't go into 30. So this would be simplest radical form, 2 root 30. I mean, I know this answer is going to be 9, but watch this. This is a C. This is like an A. This is a B. A squared plus 9 squared equals 9 root 2 squared. What the heck is 9 root 2 squared? Well, it's 9 root 2 times 9 root 2. You can multiply these 4 things in any order. So I could do 9 times 9 and root 2 times root 2. Now, 9 times 9 is 81. Root 2 times root 2 is 2, or root 4, which is 2. 81 is 162. Now, watch that. I'm going to subtract 81, and oh yeah, I get 81. Oh, A has to be 9. We realize, and we're going to learn about these triangles more, that the relationship of the legs to the hypotenuse of a 45, 45, 90 isosceles right triangle has to be this, where it's like a length, and the hypotenuse is going to be the length times root 2. Or you have the length. You could divide it by root 2. Is that right? Anyways, I don't want to. I'll figure it out myself. Okay. Kind of intense. Many of you are like, how do I know if it's simplified or not? You just got to try. Break out your calculator, start taking numbers and dividing it by perfect squares that you know. I wish my division symbol worked. So, like, divide it by 16. It's like, no, I can't do that. And then divide it by 9. No, I can't do that. Divide it by 4. I can't do that. And then you've covered all of the possible perfect squares that could be extracted by extracted out of root 30. So it's like I can't divide it by any perfect squares. Root 30 is simplest form. Cool? Cool. All right. Hope we understand. I will see you out there. Peace.